lenses and spherical mirrors. We should move to the numericals. But before solving the numericals, we have to understand whether you will give the positive or negative sign, how you will give positive and negative sign to object distance, image distance and focal length, and all this included in the sign conventions. These are the rules how you are giving positive and negative signs for these different lengths. Now, sign conventions we will cover for spherical mirrors and spherical lenses. Now, first of all, we will start with concave mirror. In concave mirror, light rays are moving like this, and according to sign convention, first rule is all the distances measured in the direction of incident ray are taken positive, and the distances measured against the direction of incident ray are taken negative. Now consider different lengths. Suppose the distance between the pole and the object is u, yani object distance, and object distance is measured from pole. All the distances must be measured from pole only. That's why we will move from this to this, and we are moving in the opposite direction of the incident ray. That's why in case of concave mirror, object distance is negative. Now come to image distance. During measuring the image distance, we also have to move from pole to image, and it is the opposite direction to the incident ray. That's why the V is also negative in case of concave mirror. Now come to focal length. Distance between P and F is the focal length, and while measuring, again you have to move from P to F in the opposite direction of the incident ray. That's why it is also negative. Now come to convex mirror. Suppose you are measuring the distance of U. Again you have to move from P to object. Again you are moving in the opposite direction. That's why in case of convex mirror also the object distance is negative. Now come to other side. Our image is now on the behind the mirror. That's why we have to measure the distance between P and image. Now you are moving in the direction of incident ray. That's why image distance is positive, and it clearly shows the image is virtual. In case of numericals also, if your V value is positive, that clearly shows that it is a virtual image. Now focal length. Again focal length is on that side behind the mirror, and the distance between P and F, it is also in the direction of incident ray. That's why focal length is also positive. In this way we have learned that U is always negative because it is object itself. That's why distance is always obviously negative. But in case of V, in concave it is negative, and in convex it is positive. And if V is negative in concave mirror, that means the image is real. And focal length, if in concave mirror it is negative, and in case of convex mirror it is positive. Now after completing this, we have to understand for the spherical lenses. In case of spherical lenses also, object distance, all the distances again measured against the direction of incident ray, it is negative, and in the direction of incident ray it should be positive. Now in this case, if you are measuring the distance between O and object, that means you have to move against the direction of incident ray. That's why U is negative in both cases. Now come to image distance. In convex lens, image is formed at the other side of the object. That means the distance is between O and image. While measuring, you have to move in the direction of incident ray. That's why V is positive in case of convex lens. but whenever it is positive, that means image is real. Now focal length, if you measuring the focal length, again it is the distance between O and F, and it is in the direction of incident ray, that's why F is also positive in case of convex lens. Now diverging lens, in case of diverging, U is always negative, but V, it is the distance between image and O, but in this case image is formed at the same side of the object, that's why while measuring the distance between O and image, we have to move in the opposite direction of the incident ray, that's why it is negative, and it clearly shows that image is virtual. And last case of the focal length, in case of measuring focal length, we have to move in the opposite direction to the incident ray, that's why it is also negative. Now one point left, that is height. All the distances measured in the upward direction of the principal axis are taken positive, and all the distances measured below the principal axis are taken negative. Now in case of height of object, it is always positive, but if the image is inverted, height of image is negative if it is real or inverted. In case of concave lens, image is erect. If the image is erect, the distance is above the principal axis, that means height of image is positive. Now in case of spherical mirror, concave mirror, height of object is obviously positive, but in case of inverted image, height of image is negative. And in case of convex mirror, height of image is positive. Why it is positive? Because it is erect, that means it is positive. That's all for sign conventions. Thank you.